Guys, do you ever wonder how your phone knows a cat from a dog just by looking at a blurry photo? Well, today we're building the brain behind that magic, a convolutional neural network, completely from scratch. Hi, I'm Daniel. Welcome to my channel where I make smart tutorials. In this video, I'll walk you through the whole process. We'll start with the basics of convolution and pooling, and then write the core CNN operations line by line. And just to keep it real, we'll compare our version to a professional PyTorch implementation to see how close we got. So if you've ever wanted to really understand how image recognition works under the hood, not just use someone else's model, this is the video for you. Also, I've left all the useful links in the description down below, so don't forget to check them out. Now guys, before we dive into the topic of the video, I want to tell you about today's sponsor, Brilliant. If you're serious about understanding machine learning and AI concepts like we're covering today, Brilliant is honestly one of the best tools out there, guys. Here's what I love about Brilliant, folks. It's not just another passive learning platform where you watch videos and hope something sticks. It's designed around hands-on problem solving that lets you actually play with concepts. This approach has been proven to be 6 times more effective than just watching lecture videos, my friends. Now guys, what really sets Brilliant apart is how it builds your understanding from the ground up. Instead of just memorizing formulas or code snippets, you're developing real critical thinking skills through problem solving. So while you're learning specific topics, like neural networks or data analysis, you're also becoming a better thinker overall, folks. And my friends, the content on Brilliant is crafted by an award-winning team from places like Stanford and MIT, Microsoft and Google. They have thousands of visual, interactive lessons covering math, science, programming, data analysis and AI. Plus, Brilliant makes it super easy to develop a powerful daily learning habit. You can learn on your computer or phone, making it perfect for quick practice sessions anywhere. The app keeps you motivated and on track to reach your learning goals one day at a time. Guys, to learn for free on Brilliant, go to brilliant.org/dansmarttutorials, scan the QR code on screen or click on the link in the description. Brilliant's also given our viewers 20% off an annual premium subscription, which gives you unlimited daily access to everything on Brilliant, folks. Thanks a ton to Brilliant for sponsoring this video. And now let's get started. Alright guys, so today we're going to build a convolutional neural network, or CNN, completely from scratch, and I'll walk you through how it works at every step. There's a great platform called Brilliant that helps you learn math and computer science interactively, and they cover the theory behind all this really well. After we look at the basics, we'll jump into the actual coding part. So first, folks, let's understand what convnets are. These are designed specifically for working with images. Unlike regular neural networks, they use something called a convolution operation, which helps them detect local patterns in images. One of the main ideas here is the convolution filter. It's a small matrix, usually 3 by 3 or 5 by 5 pixels, that slides over the image. When you apply it, guys, you get what's called a feature map. Basically, a new image where certain features or patterns from the original are highlighted. Check out this 3D visualization. You can see a 3 by 3 filter being applied to an input image and how it transforms what we see. Now, my friends, each element in the output matrix is calculated using a dot product. Basically, you multiply the filter by a small part of the image and add it all up. After that, we usually apply something called max pooling. That just means we take the biggest value from each small section of the image, which helps shrink the size of the feature map, but still keeps the most important info. A full CNN architecture goes through a few steps, guys. First, the convolutional layers pick out basic features like edges and textures. Then, the deeper layers start combining those into more complex patterns. Finally, we have the fully connected layers. These are the ones that make the actual prediction or classification. Okay, folks, now that we've covered the theory thanks to Brilliant, let's start building the whole thing ourselves in code. If you're into this kind of stuff, Brilliant has a ton of other interactive lessons on machine learning. You'll find the link in the video description. After going through the Brilliant lessons, I put together a simple little code demo in Jupyter Notebook to show how convolutional neural networks actually work. Guys, we'll start by importing the libraries we need. I'm using NumPy for the math, PyTorch so we can compare our version to a professional one, and Matplotlib to visualize the results. These are the main tools that'll help us understand CNNs, and everything loaded up fine. Here are their versions. Next, we're creating a basic synthetic dataset to test our neural network. We'll generate random 8x8 pixel images and build a binary classification task. The idea is simple, folks. If the center pixel is greater than 0, we label it as class 1. If not, it's class 0. And the dataset is ready. We've got 1,000 images, each one 8x8 pixels. You can already see a bunch of different patterns with their labels. Now let's move on to implementing the convolution operation. That's what the next code cell is for. Now guys, we're getting into the core operation of CNNs, the 2D convolution. I wrote a function called convolution2D that takes an input matrix and a kernel, and then calculates the convolved feature map. Let's run the cell and check the result. We're using an edge detection kernel here. It's a classic example of a convolution filter. The center of the kernel has a large positive value, and the surrounding values are negative. That contrast helps it highlight edges in an image. Now, folks, take a look at the result. On the left is the original image, in the middle is the edge detection filter we used, and on the right is the result of the convolution. You can clearly see the outlines that got picked up. This shows how a convolution operation helps extract specific features from an image. And now that we've done the convolution, guys, let's apply the pooling operation. This is basically a downsampling step. Our max pooling 2D function picks the highest value from each small window, so it shrinks the image but keeps the important features. We apply pooling to the result of the convolution, and the outcome is pretty impressive. The image size goes from 8x8 down to 4x4. That's a 75% reduction, but we still keep the key visual features. You can see how the strong feature values stick around after pooling. Now guys, it's time to build a full CNN class that puts all these parts together. Our architecture is simple, but gets the job done. We've now built a thing that ties everything together, including 4x3 max pooling and all the key layers for classification. We set up the weights and biases, then activation function, and normalize the output so we get probabilities at the end. Once we run the cell, the model's ready. And folks, you can see the input shape is 1x8x8. It uses 4 convolutional filters, and the output goes to 2 classes. After flattening, we get 36 features passed to the fully connected layers. We ran the first prediction, and the network labeled the image as class 1 with a confidence of 62.79%. Not bad at all, guys, especially considering it's running on random weights and hasn't been trained yet. Let's now take a peek inside the network and see what's actually going on. The Visualize CNN activation function gives us a nice look at each filter's output. So we can watch how the neurons fire, how each filter responds to input, and how the whole feature extraction pipeline works step by step. And it's pretty amazing, folks. You can actually see how each of the 4 filters reacts differently to the input image. One might pick up vertical edges, another highlights horizontal patterns, and so on. After pooling, the size shrinks from 6x6 to 3x3, but the key features are still there. When we flatten those features, we end up with 36 values, a compact version of the original image. This compressed set of features is what the network uses to make a final classification through the softmax layer. We tried it with several images and saw consistent results, my friends. Now let's see how our from-scratch version compares to a professional implementation using PyTorch. We created an identical architecture using PyTorch's built-in layers, which come with a lot of handy stuff like optimizations, computation graphs, and automatic differentiation. We also checked the number of parameters. After running the model, we compared the predictions. And it's a win, guys! Both versions have exactly 114 parameters and produce similar results. That confirms our custom CNN works just like the Pro version in PyTorch. Our architecture mirrors all the important parts: convolutional filters and pooling, activations, and parameter setup. The only real difference is in how it's coded, but the logic and results are spot on, folks. Alright folks, we did it! We built a full convolutional neural network from scratch and saw it in action. From understanding filters and pooling to writing the actual code line by line and finally comparing it with PyTorch, you now know what's really going on behind the scenes when your phone recognizes a cat pic. And seriously guys, if you enjoyed the process of breaking this stuff down and coding it out, you'll probably love exploring more with Brilliant. Their lessons really helped me wrap my head around the theory before diving into code. Links down in the description, go give it a shot and try building your own models step by step. If you're excited to try it out, or if you've already used it and have some thoughts to share, drop a comment below. I'd love to hear your experiences. Don't forget to hit that like button if you found this video helpful and subscribe for more tutorials. Thanks for watching, until next time.